The main purpose of today's discussion is to understand the surge control philosophy for pressure ratio of discharge pressure to suction pressure ratio. So let's understand the discussion. This is compressor. It is taking suction from air or process gas. It has one pressure transmitter installed in suction side, another pressure transmitter in discharge side. On DGV is installed in this compressor. It has anti-surge control valve which is venting to atmosphere in case of air operation, and it is reverse connecting redirecting back to the suction to the compressor if it is a process gas. Then in discharge side one check valve is installed, and then discharge valve, and finally it is connected to discharge system. This philosophy is used only when DGV, that is diffuser guide vane, is installed with the compressor. And so PT1 is a suction pressure of compressor in kg per cm square gauge. PT2 is a discharge pressure of compressor which is kg per cm square gauge. PT1, PT2 are connected through electrical signal to PLC or DCS, and in addition to these, all other instrumental control valves are also connected to PLC or DCS. So converting PT, TT and all other information engineering value in PLC. So surge test data. A surge test of compressor is conducted for minimum 3 IDG position and maximum any number of points. Surge pressure ratio is a discharge pressure in absolute unit upon inlet pressure in absolute unit, and surge pressure ratio is equal to average of all the surge test data. So, but please note that surge pressure ratio has to be calculated individually, and then average has to be taken. So this is the clarification for this statement. Surge pressure ratio, you have to calculate each point the surge pressure ratio, and then you have to take the average. So surge pressure ratio after taking the average of all this point is 2.074. So these are the sample of test. So P1, P2 up to 10 points and different DGB position, 10%, 20 to 100%. Inlet pressure 1.033 is same for all the points, and discharge pressure gauge 1.15, 1.14, and then lastly 1.06. After converting, you have to add 1.033. Now it is a kg per cm square absolute 2.183 to the 2.093, and taking the ratio of each point, it is 2.113, 2.103, and then 2.026. So taking the average of all the points, it is coming as 2.074. So surge line is average of surge pressure, it is coming as 2.074. X-axis is time and y-axis is pressure ratio. So it is, we can call it a surge line, it is 2.074, which is constant. Surge control line, surge pressure ratio is 2.074. Let's say surge safety margin is 5% on surge pressure ratio. Ratio is not written, it should be ratio. So surge safety margin 2.074 into 5 by 100 is 0.104. So surge control pressure ratio is equal to surge slope minus surge safety margin. It is surge control pressure ratio is 2.074 minus 0.104, which is 1.97. So now x-axis time, y-axis pressure ratio. So on surge line is 2.074 and control line is 1.97. Operating point operating pressure ratio is 1.85, which is below the control line, which is safe on time and x-axis time, y-axis pressure ratio. PID controller developed in PLC and DCS. Input data process value PV and set point SP1 controller output. Output of PID controller will give command 20 such control valve through 4 to 20 milliampere electrical signal to the positioner of anti-surge control valve to operate it. Process value PV is operating pressure ratio. Set point is average of surge test data of pressure ratio plus surge safety margin, which is constant. Logic will be PID logic. If PV is less than SP, then anti-surge control valve will close. If PV is greater than SP, then anti-surge control valve will open, and PV is equal to SP, then anti-surge control valve will be in last position. Anti-surge control valve operation, let's assume operating pressure ratio is 1.85, surge pressure ratio is 2.074, 5% margin is equal to 2.074 into 5 by 100 is 0.104, which is constant. Surge pressure ratio with margin, surge pressure ratio minus safety margin. So surge pressure ratio with margin 2.074 minus 0.102, which is 1.97. So set point is equal to surge pressure ratio with margin. So set point will be 1.970. Process value is operating pressure ratio is 1.85. So this is operating point, this is a set point. Operating point is below this, process value is below the set point. So logic of PID is a PV is less than SP, anti-surge control valve will be closed. So if the compressor operates below the surge control line, it is safe and anti-surge control valve will close. And if the operation is above the surge control line, it is not safe and anti-surge control valve will open. So operation of machine below this point is safe and above this is not safe. So valve will close when this operation is below this point and safe. So thank you. With this I have finished my lecture. Hope you will like this. If it is so, please subscribe my channel, like it and share it so that you will get the intimation of new videos. See you in the next decision. Till then, bye bye. Thank you.